We're looking at mixed exercise 5 from the first year core textbook. So this is on straight line graphs. On question 7, what have we got? So we've got a straight line. It's going through 2 points. Obviously, 3 of the coordinates are surds, which makes it a little awkward, but don't let that put you off. And then show that the line meets the x-axis at -2, 0. Okay, so first things first, let's get the equation of line L. So I need the gradient. So that's going to be change in y over change in x. So I think there's going to be some simplifying surds involved here. So which way around? I'm going to do B take away A. So change in y will be 3 plus 4 root 3 minus 3 root 3. So at least all the surds are in root 3, so it should help a little bit. And then change in x, so that's going to be 2 plus root 3 minus 1. Okay, so that's not so bad. So the 4 root 3 minus the 3 root 3 is just root 3. So that will be that the first 3 plus root 3. And then on the denominator, I've got the 1 take away 1. So the integer part will just be 1. And then I've got plus root 3. Okay, so obviously that's got an irrational denominator. So I could rationalize the denominator at this stage. I think I'll hold off. If you've tackled this question and that's how you did it, that's absolutely fine. I think I'll just wait and see whether how much of that I need to worry about. So I'm going to use y minus y1 is m times x minus x1. So I can use either of these coordinates. That one is certainly looking the simpler one to me. So I'm going to use the coordinate 1, 3, root 3. So I've got my gradient there. I've got my x coordinate there. I've got my y coordinate there. So y minus my y coordinate is my gradient times x minus my x coordinate. Okay, and so yeah, I'm definitely going to have to think about simplifying, but I'm also now going to think about what I'm actually after, because I don't need the full equation of the line, that is the equation of line L, but obviously it would need simplifying if that was going to be my final answer. But I'm showing, I'm trying to find where it meets the x-axis. So see, if you think about where a straight line meets the x-axis, so that's where it's meeting the x-axis, and that's always at y is 0. So I'm going to substitute y is 0 in, and then I think I've probably delayed as much as I can before I have to start simplifying. So if y is 0, that's going to become 0 minus 3 root 3. So obviously that's just minus 3 root 3, and then all this business here. So like I said, you might have rationalized the denominator when you've got your gradients, and that would then be saving you some effort at this point. Okay, so I'm going to, as I normally would, I know this looks more awkward than your average question, but normally what I would do at this stage is multiply up by that denominator. So I'm still going to do that. So I've got the minus 3 root 3 on the left-hand side, which I am now going to multiply by 1 plus root 3. I don't need the brackets around the first term. I've just put them there for neatness. So then I've got the 3 plus root 3. I do need brackets there, times x minus 1. Okay, so now I'm going to multiply all these brackets. So I have got minus root 3 times 1. Sorry, minus 3 root 3 times 1. So that's minus 3 root 3. I've got minus 3 root 3 times root 3. So that is going to be minus 3 times 3. You could put these into your calculator. I suspect it will give it to you as a surd, but basically that is, so if you think about what's going to happen if you do minus 3 root 3 times, sorry, you can't see that, minus 3 root 3 times root 3, well, the root 3 times the root 3 is 3, so that's minus 3 times 3. Anyway. Okay, so that's the brackets on the left-hand side expanded. So on the right-hand side of that equals, I've got 3 times x. So this is all this is expanding out double brackets. So that's 3x. I've got 3 times minus 1. So that's minus 3. I've got root 3 times x. So plus root 3 x. Yeah, be careful. So that x is not inside the square root, and then I've got root 3 times minus 1. Okay, so I'm basically trying to find x. So I'm going to take all my non-x terms over to the left-hand side. So I've got the minus 3 root 3 and the minus 9. I'm then going to add that 3 over, and I'm going to add that minus root 3 over. And then what I'm also going to do in the same stage of working is factorize. So those 2 terms I've highlighted in blue will be left on the right-hand side. I'm just going to take a common factor of x out. Okay, then I'm going to tidy up the left-hand side. So what have I got there? I have got, so if I collect my root 3 terms together, I've got minus 3 root 3 plus root 3, so that's minus 2 root 3. I've got minus 9 plus 3, so minus 12. I can take out a common factor of minus, sorry, that's not minus 12 in the slightest, is it? And I realised as well that also was not going to give me the right answer. That's minus 6. Okay, that's better. So if I take out a common factor of minus 2, that gives me root 3 plus 3. So actually I've managed to get away without having to rationalise the denominator. So if I wanted then to just get x, I need to divide through by 3 plus root 3. Oops, I can't see that. Okay, so all I'm doing there is I'm dividing through by that. So it's coming down to the left-hand side there. Obviously, I've got them written the opposite way round, but those brackets are the same. Root 3 plus 3. Doesn't matter if I've got it written the other way round. So basically, they are going to cancel. So I do end up with x is 2, and then let's just write a really clear conclusion. So therefore, line L intersects the x-axis at minus 2, 0. Maybe rewriting probably a little bit neater than that, hopefully, which is what we were trying to find there. Okay.